My challenge today was to complete a Leetcode problem called reverse linked list using Dart in 90 minutes. So I started out by just finding the problem on Leetcode and reading through the description just to get a basic overview of the problem. They had some nice diagrams and some example test cases with their inputs and expected outputs. They also had some example code showing their implementation of a list node. The requirements for the problem are pretty self-explanatory. You're given the head of a linked list and you need to somehow reverse it. If you're unfamiliar with how linked lists work, it's a data structure that is a series of nodes. Each node is an object that contains a value and then a reference to the next node in the list. So although I hadn't actually completed this specific Leetcode problem, I have reversed a linked list before. That code was written in Typescript, which is the language I'm most familiar with. So I decided I'd try to solve this problem first using Typescript, and then afterwards translate that code into Dart, which is a language I've never used before. After looking at that code for a minute, I noticed the control flow was a bit hard to understand just from looking at it, so I decided to write some pseudocode to try to help me. I was still having some difficulty fully wrapping my head around the code, and I just wanted to make sure that I really understood what was going on. Considering I had given myself a whole hour and a half to complete this problem, I figured I had time to try making some diagrams, and I was honestly looking for an excuse to use this program Excalidraw. So I started out by writing out an example list and labels for the 3 nodes that I need to keep track of, which are the current node, the next node, and the previous node. In my previous implementation, I started out by switching the head and tail of the list, but in this one, since I don't have a reference to the tail, I had to find another way. So the way that you can think about these 3 variables, current node, previous node, and next node, is that they're just pointing to a specific node in the list. And we're going to use the 3 of them to rearrange where every node in the list points, which again is determined by a property on each node called next. We start by declaring current node and setting it equal to head, which is the first node in the list, which happens to be the number 1 in this case. Then we declare previous node and next node, but we don't assign them any values yet. Then we enter the loop. The first step in the loop is to set the next node variable equal to the current node's next property, which again is the node that follows the current node. After that, we set the current node's next property to the previous node. In this case, the previous node is null, which actually makes sense because this node should end up being the tail of the list, which should have a next property of null. After that, we set the previous node equal to the current node and the current node equal to the next node. Then we start the loop over. The second time through, the next node gets set to the current node's next property, and then the current node's next property gets set to the previous node, which this time is the node that originally came before it. So the pattern we repeat is to take the variable next node, set it equal to the current node's next property, so that when we change it, we still have a reference to what was once the next node. Then we change the current node's next property so that it points to the previous node. Then we set up for the next iteration through the loop by setting the previous node equal to the current node and the current node equal to the next node. So as I ran through this, I noticed at the very end I was going to run into an issue where the current node is going to be set to the next node, which on the very last iteration is going to be null. So I figured I could add a check after I set the current node's next property for the very last time and do an early return. So at this point, I felt like I had a pretty good understanding for the problem and it was time to just code it up. Again, I started with Typescript just because I'm more comfortable with that language, but eventually I knew I was going to need to redo it using Dart. Whenever I'm doing Leetcode problems, I like to start out by just thinking of edge cases and seeing if I can do early returns for those cases. I noticed in the constraints for this problem that the number of nodes in the list could be anywhere between 0 and 5,000. So the 2 edge cases I considered were if the list is 0 nodes long or if the list is 1 node long. Either way, I could just return the head of the list. Then after that, I pretty much just translated all the pseudocode into TypeScript code, which was pretty easy. One consideration I had to make was, when do I exit the loop? I figured if I was going with the early return technique, then it didn't really matter, but in the spirit of making my code more understandable, I decided to try looping until the next node isn't null, and then seeing if I could rearrange the order of some of the logic within the while loop. This also meant that the condition for looping was never going to be met as long as the next node was instantiated with a value of null. So I decided to start it out with the value of current node.next, which is what it would end up getting set to anyways. And then I decided that I could actually just use a do while loop. This seemed like a great solution, and then I didn't end up having to set next node equal to the same value twice in a row. I spent a little bit of time trying to rearrange the logic within the loop so that I wouldn't have to do an early return, and when I reach the end of the list, I don't end up setting current node equal to a null value. I tried a couple things, but they didn't seem to be working, so I just decided to return the previous value, which by the end of the loop iterating should be equal to the head of the list. And that ended up getting me to the solution, so I submitted it, and it passed. So at this point, I was running really low on time. I only had a half an hour left, and I still had to rewrite all this code using Dart, which is a language I knew almost nothing about. So I started out by just going to their website. They had an intro to Dart page and also a cheat sheet. So I did some quick reading on these pages to get a feel for the general syntax of the language. It all felt pretty familiar from what I'm used to. It's a strongly typed language. Everything is an object, even things like numbers. They put a strong emphasis on something called null safety, where a variable can only be assigned to null if it's declared as nullable. It includes things like conditional assignment and conditional property access, which looks similar to nullish chaining in JavaScript. And conditionals and for loops look basically exactly the same as JavaScript, from what I could tell. So after getting a really basic understanding of the language, I decided to just go into the problem and try writing it up. I got the initial check for edge cases working fine, and then after implementing the rest of the code, I was running into an error. I realized really quickly that I was trying to access a property that could be null, so I added that check for properties that are potentially null. That fixed that problem, but then I was getting another error. It seemed to be a related problem where I was trying to assign a property that was potentially null. So I tried to solve it with the same technique, and only now that I'm rewatching the video, I noticed I deleted that question mark before I ran the code. I have no idea why, but that sealed my fate, and I ended up trying to resolve that error until time ran out. After a few more minutes, I decided to retry using that same solution, and sure enough, it worked. So I guess I had written the correct code for the solution before time was up, and I think I'm just gonna give myself the win.